Welcome to CAD Engineer. In this video, we are going to start AutoCAD training for beginners. This is my email ID engineercadd@gmail.com. So if you have any queries, you can put me on this mail ID. So what we are going to cover in this chapter 1 content outline, let's see. So what is AutoCAD? Who can use AutoCAD? What is the differences between AutoCAD and AutoCAD LT version? Introduction to engineering drawings, classification of engineering drawings, history of AutoCAD, System requirement for AutoCAD installation 2024, graphical user interface of AutoCAD, coordinate system in AutoCAD, type of coordinate system, absolute coordinate system, exercise 1 on absolute coordinate system, relative rectangular coordinate system, exercise 2 on relative rectangular coordinate system, relative polar coordinate system, and exercise 3 on relative polar coordinate system. Let's start. Chapter 1. What is AutoCAD? So if we talk about the full form of AutoCAD, AutoCAD stands for Automatic Computer Aided Design. So it is a software that is used for precise 2D and 3D drafting, design, and modeling with solids, surfaces, mesh objects, and documentation features and more things. It includes features to automate tasks and increase productivity such as comparing drawings, counting, adding objects, and creating tables. It also comes with 7 industry-specific toolsets for electrical design, plant design, architecture layout drawings, mechanical design, 3D mapping, adding scan images, and converting raster image. AutoCAD enables user to create, edit, and annotate drawing via desktop, web, and mobile devices. Next, we'll see who can use AutoCAD. So AutoCAD is an Autodesk product. It is used by students, architects, designers, engineers, project managers, real estate developers, and construction professionals to create 2D and 3D drawings. Next, we'll see what is the difference between AutoCAD and AutoCAD LT version. AutoCAD LT is a powerful 2D CAD software used for precision, drafting, and documentation. AutoCAD includes all the features of AutoCAD LT and plus additional features to benefit productivity such as 3D modeling and automation of repetitive processes. AutoCAD also lets you to customize the user interface with APIs and add-on apps. With AutoCAD, users are able to work more efficiently with 7 industry-specific toolsets to enhance automation and productivity for tasks in architecture, mechanical design, electrical design, plant design, plumbing, converting raster image, geographic information system, and 3D mapping. Next, we are going to see Introduction to Engineering Drawings. Engineering drawing is the common language of engineers across the globe. Engineering drawing provides the required knowledge and the process of creating for any engineering or architectural application. Engineering drawings drawn in a logical way, following the standard and formats, help an efficient way to communicate the design information. Engineering drawing describes a specific component in a way that the viewer of a drawing understands without misinterpretation. An engineering drawing, a type of technical drawing used to fully and clearly define the requirement of engineering items. So if you're making a drawing in the one part of a country and we are sending to another part of a country, so that will be easily understood by the engineers because that is made by following the set of instructions that is followed by the engineers. Classification of engineering drawings. Engineering drawings are usually more complex than other drawings because it includes all the engineering of how the product goes together as a complete product. Engineering department usually have engineers who do the designs. Let's see the type of engineering domains drawing can be created on AutoCAD. Electronics engineering drawing, where we can make schematic, circuit board, and PCB kind of drawings. Then electrical engineering drawings, where we can make wiring diagrams, electrical installation of drawings. Mechanical will make parts, assembly, fabrication, production drawings, fits, forms, and function drawings. Civil engineering, we can make plans, elevation of homes to be built, foundation drawings. So these are the different domains, electronics, electrical, mechanical, and civil, on which engineering drawings are classified. Next, we are going to see history of AutoCAD. AutoCAD is a commercial computer-aided design and drafting software application by Autodesk. The first release of the software started with version 1.0 in December 1982. The software has been continuously updated since its initial release. Mikkel Ritter is a co-founder of AutoCAD application. Initial release of AutoCAD version come with the name like AutoCAD R 1.2, AutoCAD R 1.1, AutoCAD R 1.2 and so on. Then after year 2000, Autodesk start launched the AutoCAD version with the year name. So AutoCAD 2000 is the first version which came with the year name in year March 1999. Then after that, it is continuously released version with the name of years. Now the latest version in the market is AutoCAD 2024, which is launched on March 28, 2023. Next, we are going to see graphical user interface of AutoCAD. The graphical user interface is the screen that shows us when you first start AutoCAD. It have the following major items: menu bars, tabs, and panels. So when we open the screen, this is how the screen will be look like. Let's go to the software and understand the graphical user interface. So to open the software, we can click on the desktop icon, double click, and it will be open the software. So initially it will take little time to open. Once it is open, we can see. So here our software screen is open. So once it is open, we can see the two things here. One is list view and one is a grid view. So what it's showing the recent project that we have worked on. Next, here we have AutoCAD Start tab where we can see the AutoCAD software name AutoCAD 2024, and then here we have two options, open and new option. So if you have already existing drawing is there, you can click on open and you can select that document and you can open it. Like if you're working for first time, you can click on new and you can enter into the software by clicking on that. So once we enter on the software, this is how our graphical interface screen will be open. Now we'll understand what we have on the screen. So at the top, we have application menu. When we click on the application menu, we'll get the options like we can take a new drawings and sheets. We can open existing documents. We can save our projects from here. We can do save as, or we can import PDF, TZ and other formats file. We can export the files. We can publish the documents and we can print the file. We can take more drawing utilities options from here and we can close current file and all the files. Next, at the top we have quick access toolbar from where we directly take new, open, save as. Then we have new options in newer version like open from web and mobile, like where that same document that you are making in AutoCAD that can be open into your mobile and on the web also. Then we can also save this file that we are making. We can save onto mobile and web and we can print the files. We have option undo, redo, and we can also share our drawings. Then here we have a title bar. The title bar will find the software company name, software name, and the file name that we have opened currently. And here if you want to search anything, you can put a keywords and you can search it. Next, we have ribbon tabs, home, insert, annotate, view, manage, output, express tools. So these are what like our ribbon tabs. Then this under this we have completely, we call it ribbon bar. So on the ribbon bar, we have different panels. We have a draw panel, modify panel, annotation panel, layer panel, block panel, property panel, group panel, utilities, clipboard, and view panels. And here we have a drawing switcher panel. So when you have a multiple drawings, like I have two drawings I opened, so you can click onto which drawing you want to switch it. So immediately you can switch one drawing to another drawings if multiple drawings are open here. Then here we have like visual styles we can control, or view controls we can do it. Visual styles when we working with the 3D models, in that cases we can use this visual styles. And the same view modes also we use it when we are working in 3D to change the views, we'll use view modes. At this side we have a view keyword. View keyword is also used for when we're working in 3D environment to change the view. And if you want to work in 2D also, we can keep always into the top view. So this we also call as world coordinate system. And here we have a navigation panel. From the navigation panel, zoom, rotate, and that options we can take it from here. And this we have UCS, user coordinate system, and the cursor that we are seeing in the screen, that is called crosshair. And here we have a command window. In the command window, we can type the command names or we can put the shortcuts. And this we have like model. Right now that which window we are working, that is called model space, and we have paper space window. So we can easily switch by clicking on model and the layout window, paper space to the model window. Then here we can see the status. If anything we are doing on the screen, that will show you the status of the cursor here. And we have some functions tools. And if you want to customize something, you have some options by clicking on these three lines. We can have customize our tools by ticking and unticking. We can add or remove from the screen panel. You see that now It's showing my coordinates, that status of my cursor, how my cursor, where my cursor is exactly on my screen. So this is about AutoCAD graphical user interface. Next, we are going to see coordinate system in AutoCAD. Coordinate system. For the AutoCAD user, understanding the coordinate system is very important. Every point in AutoCAD drawing file can be identified by its XYZ coordinate. In the most 2D drawing, the Z coordinate value is always 0. This system of coordinate is referred to in AutoCAD as the Word Coordinate System, or WCS. So when we're working in AutoCAD, we have to always keep this coordinate in our mind. So that will be telling about the sign rule. In the first quadrant, X value and Y value will be positive. In the second quadrant, X will be negative and Y will be positive. In the third quadrant, X will be negative and Y will be negative. In the fourth quadrant, X will be positive and Y will be negative. When we're working with the coordinate system, it will help us to maintain the sign and taking the values. Next, we are going to see type of coordinate system in AutoCAD. There are 3 types of coordinate system: absolute coordinate system, relative rectangular coordinate system, and relative polar coordinate system. So next, we are going to see absolute coordinate system. Absolute coordinate systems are based on the uses origin 0, 0, which is the intersection of x and y axis. Use absolute coordinate system when you know the precise x and y value of the point. So the syntax used for absolute coordinate system is x, y. So we have one example here where we'll understand how to calculate the coordinates and how we'll create this by using absolute coordinate system in AutoCAD. So here I have a rectangle which have size 4 by 2. If you see this rectangle, we have made this rectangle at 2 distance in x and 2 distance in y. So the value of this point will be 2, 2. Next, we have to calculate the coordinate for the next point. So that will be, we are calculating from the origin. As per the definition, the absolute coordinate system are based on the uses origin 0, 0. So what are the value you are taking, that will consider from the origin. So we know like this gap is 2 and this distance is 4. So x value will become 6 and we are not moving anything in y direction. So y will be remain 2. So the next coordinate will be 6, 2. Now next we have to calculate the coordinate value for this point. So again we will take this from origin. So we know from here to here this distance is 2 and this is the 2 length. So this y distance will become 4. So next coordinate will become 6, 4. Now next we are moving in negative x direction. So again when we're moving in next direction, so we reduce the given value from the coordinate value. So x is, we have 6 here. So 6 minus 4, that will be 2. And y we are not moving anything, so y will be remain as it is. So the distance will become 2, 4. Now again we have to come at the origin point. So again we'll take the value in negative y direction. So when we're going to negative y direction, so value will be like subtracted from the original value. So initially this is 4. So 4 minus this 2 distance, so we'll get 2, 2 is my last value. Now we'll use this coordinate values to create this figure in software. Let's see. So we'll use line command. For taking line command, we can take a shortcut L enter, and then we'll give the coordinates one by one and we'll create this diagram. Let's see in the software. So let's see how to create that rectangle by using this coordinate value. So first we'll take a line command by using shortcut L enter. So we'll type on screen L enter and we'll specify the first point on the screen by giving coordinate 2, 2, enter. Now next I have to specify the next value 6, 2, enter. Then we'll give the next value 6, 4, enter, and next value 2, 4, enter, and next value 2, 2, enter. And then last we'll press escape button to cancel the command. So this is how we can make a rectangle by using absolute coordinate system method. Next we are going to see exercise 1. We'll find the coordinate value with the absolute coordinate system to solve this exercise. Let's see how to solve this exercise. So in this exercise, we are considering this point to be origin point. So the value of this point will be 0, 0. Now we have to calculate the value for this point. So this will be from here to here, the distance is 75, and in y direction we are not going anything. So x will be 75 and y will be 0. Next we have to find the coordinate value for this point. So we know x is already 75. In y direction we are moving total 45 distance. So the coordinate value for this point will be 75, 45. Now we have to go into the negative x direction side. So we have to find the coordinate value for this point. So we know x is 75, so x 75 minus 25, that become 50. And y we are not moving anything, so y will be remain as it is 45. So 50 comma 45 will be the coordinate value. The next we have to find the coordinate value for this point. So we are coming in negative y direction, so we'll reduce the y value. So x will be remain 50, y is 45, 45 minus the given distance of this line is 15. So 15 minus 45, that is 30. So 50 comma 30 will be the next coordinate. Now we have to find the coordinate value for this point. Again, we are moving in x direction. So we reduce the x distance, 50 minus 25, so x will be 25, y is equal to 30. Next, again in negative y direction, we have to find the coordinate for this value. So x is 25, y is 30 here, so we'll reduce this distance, 30 minus 15, so x is equal to 15. So 25 comma 15 will be the next value. Now we have to find the coordinate value for this point. Again we are moving in x direction, so 25 minus 25, so x will be 0 and y will be 15. Now again we are coming to origin point again, so x is 0 and y is equal to 15, so 15 minus the total 15 distance of the length of the line, so x and y both become 0. Now we'll take this coordinate and we'll create the diagram on the software. So let's see how to make exercise 1 by using this coordinate value. So first of all, we'll take line command, we'll type line, enter. Now we'll specify the first coordinate value 0, 0, enter. Now we'll specify the next coordinate, that is 75, 0, enter. Next coordinate will be 75, 45, enter. Next coordinate 50, 45, enter. Next coordinate 50, 30, enter. Next coordinate 25, 30, enter. Next coordinate 25, 15, enter. Next coordinate 0, 15, enter. The last coordinate 0, 0, enter, and one more enter to cancel the command. So this is how we have completed exercise 1 by using absolute coordinate system method. Next we are going to see relative rectangular coordinate system in AutoCAD. Let's understand the definition. After locating the first point, your next point can be entered by specifying the next coordinate related to the first point. Syntax of relative coordinate system @x, y. Let's understand with the example how to find out the coordinates and how we'll create this on software. So here we have created this rectangle in x2 distance and y2 distance. So coordinate value for this point will be 2, 2. Now next we have to find out the coordinate value for the next point. For this point we know from here to here total distance of the line is 4. So x will be 4 and y we are not moving anything, so y value will be 0. So the coordinate will be @4, 0. Now we have to move in y directions. So we are not going in anything in x direction, so x will be 0 and y value will be 2. So @0, 2 is the value for this point. Now we have to find out the coordinate value for this point. Now moving in negative x direction, so x value will become -4 and y will be 0. So value for this point will be @-4, 0. Now again we have to move to the origin point. So we are moving in negative y direction. So x will be 0 and y distance will be -2. So the value will be @0, -2. So these are the result coordinate values. Now we're making the software by taking a line command. We'll take L enter and we'll specify the coordinate. First coordinate we can specify by clicking on the screen, or we can give the 2, 2 as the origin point, and then we'll give the next coordinate. Let's see in the software. Let's see how to create the rectangle by using relative rectangular coordinate system. So first we'll take a line command. We'll take by typing the shortcut L enter. Now we have to specify the first coordinate point from where we have to start. So here we can specify a coordinate value, or we can click in the screen anywhere to start it. We'll click here. Now we'll specify the next coordinate value, that is @4, 0, enter. Next coordinate @0, 2, enter. Next coordinate @-4, 0, enter. And the next coordinate @0, -2, enter. And again hit enter or press escape button to cancel the command. So this is how we have created this rectangle. Next, we are going to see exercise number 2. We'll find the coordinate value with relative rectangular coordinate system. So let's see the exercise, how to find the coordinate and create on the software. For creating this exercise, we have to keep that plus and minus in our mind before taking a coordinate. So we are starting this diagram from this point. So we can click to the first point on the screen, and now we'll have to find the coordinate value for the next point. So here, from here to here, we know the total distance is 15. So the x will be 15 and y will be 0. So the coordinate value will be at the rate 15, 0. Now we are moving in negative y direction. To this point we have to come. So we know this total length of line is 50 and x we are not moving anything. So at the rate 0, minus 50 will be the value. Now we have to come to this point. So for this point value, so we are moving in negative x direction. So y will be 0. So the coordinate will be at the rate minus 15, 0. Now we have to find out the coordinate value for this point. So we know we are moving in positive y direction. So x will be 0 and y value will be 50. So at the rate 0, 50 will be the value. Now again, we'll start this diagram from this point. So value from here to here, that is 15. So at the rate 15, 0 will be the value for point. Now we have to come at this point. So we know this is total 10 distance in x and this is total 10 distance in y. So the coordinate value for this point will be at the rate 10, minus 10. Now we are moving in the upward direction in positive y direction. So value for this point will be at the rate 10, 10. Now we have to come at this point. So we know this is total 15 distance. So the value will be at the rate 15, 0. Now we have to come again negative y direction at this point. So the value for this point will be at the rate 0, minus 50. Now we have to come to negative x side distance, so that the value will be at the rate minus 15, 0. Now we have to find the value for this point. So that will be at the rate minus 10, 10. And now again we have to come this point. The value will be at the rate minus 10, minus 10. Now again we are moving in negative x direction. So the value for this point will be at the rate minus 15, 0. Once the sketch will be closed here, we'll start from here. So the coordinate value for this point to here, this will be at the rate 15, 0. Now next, we have to come to this point. So again, the value will be at the rate 0, minus 50. Now, for closing the sketch, we have to come at this location. So the value for from this point to this point, that will be at the rate minus 15, 0. Now let's see, by using this coordinate value, how to create this diagram in the software. Now we will create the diagram by using the result coordinate values. So start the diagram. We'll take first the line command, li, ne, enter. So first we have to specify one point on the screen from where we have to start. So we can click anywhere to start. Now we'll specify the next coordinate value at the rate 15, 0, enter. Next at the rate 0, minus 50, enter. Next at the rate minus 15, 0, enter. Next at the rate 0, 50, enter. We'll press escape button to cancel the command. We'll take command again by type L, enter, and we'll click on the point to start. Next at the rate 15, 0, enter. Next at the rate 10, minus 10, enter. Next at the rate 10, 10, enter. Next at the rate 15, 0, enter. Next 0, minus 50, enter. Next at the rate minus 50, 0, enter. Next at the rate minus 10, 10, enter. At the rate minus 10, minus 10, enter. Next at the rate minus 15, 0, enter. We'll press escape button to cancel it. Again we'll take line command, enter. We'll click on the next point at the rate 15, 0, enter. Next at the rate 0, minus 50, enter. Next at the rate minus 15, 0, enter, and press enter to cancel the command. So this is how we have created this diagram by using relative rectangular coordinate system method. Next, we are going to see polar coordinate system in AutoCAD. Let's see the definition. After locating the first point, polar coordinate system can be used when you need to draw the next point at specified angle. Syntax of relative coordinate system distance less than angle. Let's understand how we can work with coordinate system. So before working in the polar coordinate system, we should have in our mind this coordinate rule. So we have four quadrants. First, where the angle range will be 0 to 90 degree. Second quadrant, where the angle range will be 90 to 180. Third quadrant, where the angle range will be 180 to 270. And fourth quadrant, the angle range will be 270 to 360 degree. So when we creating any lines at an angle, so we have to keep this coordinate in our mind so we can easily create that angles. Now I have one example here. So I made this 30-degree angle here. So if you see this carefully, this line, according to the coordinate rule, this line is going between 0 to 90. So the angle will be 30 degree. Now if you see this line carefully, so here this line is going 90 to 180 degree. So the angle of this value will be, if we complete this here, total this angle, that is total 180 degree. So we can calculate this angle. So angle is 180 minus 30, the total angle is 150. So if you want to draw this line, so we have to draw it 150-degree angle slope, then only we can draw it exactly. So this is how we have to keep this coordinate in our mind and we can create anything in the software. Let's see in the software how to create these things. To create this diagram, let's create it. I'm taking a one line of 10 distance. Now from here, I'll take an angle at the rate 10 less than 30. Enter. So this is why I exactly make 30-degree angle. Now I'll make this at 150-degree angle. I'll create a line of 10 distance. Enter. And again take a line tool and click on this point at the rate 10 less than 150. Enter. Let's see some example on polar coordinate system. So syntax we have to keep in our mind at the rate distance less than angle. So here I have a triangle which have each side of 15 distance and all the internal angle have a 60-degree angle. So here I'm considering this point to as a origin point 0, 0. Now I have to locate the value of this point. So if we know from here to here the distance is 15 and angle is 0 degree. So next coordinate value will be at the rate 15 less than 0 degree. Now I have to calculate the coordinate value for this point. So that we can calculate from here. So we know this angle is 60 degree and we can calculate the remaining angle. So we can calculate easily 180 minus the given angle. So we'll get the value that is 120 degrees. So the value for the next point will be at the rate 15 less than 120. Now we have to calculate the value for this point to come downward side. So we know from here we'll draw a straight line. We know this is total angle is 60 degree and this angle is 180 degree. So this is adjacent angle of this. So this is 60 degree. So we can calculate 180 plus 60-degree angle and that will be 240 degrees. So for making this line, we'll give the distance, we'll give the coordinate at the rate 15 less than 240 degrees. Let's see one more example. I have a square which have all the sides of 15 distance. We are considering this point to be 0, 0. Now we have to find the value for the next point. So we are moving in this direction. So the next value will be at the rate 15 less than 0. Now we are moving in upward direction. So we know this angle is 90 degree. So at the rate 15 less than 90 degree is the value for this point. Now we have to come to this point. So we know that we are going to this direction. So this direction, the angle value will be 180 degrees. So at the rate 15 less than 180 degree. Now moving downward direction. So we know the downward direction, the angle will be 270 degree. So the next coordinate will be at the rate 15 less than 270 degrees. Let's see on the software how to create these diagrams. So while making this diagram, we have to always keep the coordinate system in our mind. So let's create first isosceles triangle. So first we'll take a line command, line, enter. Now we can specify the origin 0, 0, or we can click anywhere on the screen to start. After giving a first point, we'll define the next value at the rate 15 less than 0 degrees, enter. Next, at the rate 15 less than 120. Next, at the rate 15 less than 240 degree, enter. Let's create the square. We'll take line command, enter. We click on the screen anywhere at the rate 15 less than 0, enter. At the rate 15 less than 90 degrees, enter. At the rate 15 less than 180 degrees, enter. At the rate 15 less than 270 degrees, enter. So this is how we can create the diagram by using polar coordinate system method. Next, we are going to see exercise number 3. We'll find the coordinate value with polar coordinate system. The syntax used for polar coordinate system at the rate distance less than angle. Let's see this exercise, how to find the coordinate. So here we are considering this point as origin points. So the value for this point will be 0, 0, or we can click to start. Now we have to find the coordinate to draw this line, that will be at the rate 30 less than 0 degree, because it's a straight line. Now I have to find the value for this line. So we know this line having angle of 60 degree. So the coordinate will be at the rate 30 less than 60 degree. Now I know this angle is 60 degree. So I have to draw this line. For that we have to calculate this outer angle. So what we can do, we can draw a straight line, and we know this is total angle is 180 degree, and this is adjacent angle of this angle, so that will be 60 degree. Same here, this will be a 60 degree angle. So from here to here the angle become 300 degrees. So the value will be at the rate 30 less than 300 degrees. Now we have to draw this line. For that the angle value will be at the rate 30 less than 0 degree, because it's a straight line. Now again we have to find the angle for this line. So we know the internal angle is 60 degree, and this line from here to here we can consider the angle is 180 degree, and the remaining angle is 120 degrees. So we can subtract this from total angle, the remaining this angle, so we'll get the angle value. So what we'll do, we'll subtract 360 minus 120, so the angle value will be 240 degrees. At the rate 30 less than 240 degree will be the coordinate of this line. Now we have to draw this line. This is the same line that we have drawn here. So we can take the same angle at the rate 30 less than 300 degrees. Now we have to draw a line in this direction. So we know this is a straight line. The value of this line be at the rate 30 less than 180 degree. Now we have to find the angle of this line. So this is the same line that we have drawn here. So we can take the same angle at the rate 30 less than 240 degrees. Now here we know this internal angle again 60 degree here. So we can calculate this angle. So 180 minus 60 degree, so the angle will be 120 degree. So the angle will be at the rate 30 less than 120. Now this line we can draw at 180 degree, because the straight line at the rate 30 less than 180 degree. Now we know the slope of this line, that is 60 degree, so we can draw at 60 degree at the rate 30 less than 60 degree. So here we have to find the angle of this line. So we know this is the same line we have drawn here. So the angle value of this line will be at the rate 30 less than 120 degree. Let's see on the software how to create this diagram by using this coordinate value. Let's see how to create this star by using the given coordinate value. So first of all, we'll take line command while taking L, enter. I will specify first point of the screen to start. After giving starting point, we'll define the next coordinate value at the rate 30 less than 0, enter. Next coordinate at the rate 30 less than 60, enter. Next at the rate 30 less than 300, enter. Next at the rate 30 less than 0, enter. Next at the rate 30 less than 240, enter. Next at the rate 30 less than 300, enter. Next, at the rate 30 less than 180, enter. Next, at the rate 30 less than 240, enter. Next, at the rate 30 less than 120, enter. Next, at the rate 30 less than 180, enter. Next, at the rate 30 less than 60, enter. Next, at the rate 30 less than 120, enter, and one more enter to cancel the command. So this is how we can use polar coordinate system method to create the star diagram.